Okay, let's analyze a series RLC circuit. So here's the question we are looking at today. We have an AC power supply giving us 220 volts at 50 Hz. And connected in series to this supply are three components. A resistor with a resistance of 20 ohms, a capacitor with a capacitive reactance of 25 ohms, and an inductor with an inductive reactance of 45 ohms. The question asks us to find the current flowing through the circuit and the phase angle between the current and the voltage. We have four options here. Option 1 15.6 amps and 45 degrees. Option 2 7.8 amps and 30 degrees. Option 3 7.8 amps and 45 degrees. And option 4 15.6 amps and 30 degrees. To figure this out, we'll break it down into a few steps. First, we'll calculate the net reactance in the circuit. Next, we'll use that to find the total impedance of the circuit. Then we'll be able to calculate the current using Ohm's law. And finally, we'll determine the phase angle. Alright, step 1. Let's calculate the net reactance, which we'll call X. In a series RLC circuit, the net reactance is simply the difference between the inductive reactance XL and the capacitive reactance XC. We are given that XL is 45 ohms and XC is 25 ohms. So our formula is X equals XL minus XC. Plugging in the numbers, X equals 45 ohms minus 25 ohms. That gives us a net reactance X of 20 ohms. Now step 2. Calculating the total impedance, which we denote as Z. The total impedance of a series RLC circuit is found using this formula. Z equals the square root of R squared plus X squared, where R is the resistance and X is the net reactance we just found. We are given R as 20 ohms and we calculated X as 20 ohms. So Z equals the square root of 20 ohms squared plus 20 ohms squared. That's the square root of 400 ohms squared plus 400 ohms squared, which equals the square root of 800 ohms squared. We can simplify the square root of 800 by saying it's the square root of 400 times 2. So Z equals 20 times the square root of 2 ohms. Okay, step 3 is calculating the current I. Using Ohm's law for AC circuits, I equals V over Z, we substitute the given voltage and the impedance we just calculated. This initial expression simplifies and then we rationalize the denominator to arrive at the exact current value. Finally, to get a numerical approximation, we use the value for the square root of 2 and perform the final calculation. Rounding to one decimal place, the current is approximately 8 amps. Finally, step 4. Let's calculate the phase angle, which we call phi. The phase angle between the voltage and the current in a series RLC circuit is given by the formula. The tangent of phi equals the net reactance X divided by the resistance R. We found X is 20 ohms and we are given R is 20 ohms. So the tangent of phi equals 20 ohms divided by 20 ohms. That means the tangent of phi equals 1. To find the angle phi, we need to find the angle whose tangent is 1. Phi equals the arctan of 1. And the angle whose tangent is 1 is 45 degrees. Since our inductive reactance XL 45 ohms is greater than our capacitive reactance XC 25 ohms, the circuit behaves inductively overall. This means the current lags behind the voltage and the phase angle is positive 45 degrees. So putting it all together, we calculated the current to be approximately 7.8 amps and the phase angle to be 45 degrees. Let's look back at our options. Comparing our results to these options, we see that option 3 matches our calculated values exactly. Therefore, the correct option is 3.